During this 6th week, we are going to explore chapter 5. This is chapter 5, and the topic is discrete probability distribution. We have the fundamental idea of probability already, but here we'll be working on a special type of probability distribution, which is called the discrete probability distribution. Let's see what is discrete probability distribution. Before we understand the discrete probability distribution, there are a couple of things that we need to know. And the first one we need to know is the random variable. So you'll see this over and over again throughout the remaining part of this course. So you must know what is a random variable. When I say random variable, it is a numerical value associated with each outcome of the probability distribution. So when you perform any probability experiment, the outcome that you get, we represent that by X, and it is called the random variable. For example, if I roll a six-sided die, the outcomes are 1, 2, 3, 4, 5, 6. These numbers are the random variables. Or if I flip a coin, then you'll get head or a tail. So that head or a tail, that is your random variable X. So when we say a random variable, it is a numerical value associated with each outcome of any probability distribution or experiment. That is the first thing. Now the random variables, they are of two types. The first one is called the discrete random variable, and the second is called the continuous random variable. So there are two types of random variable. When I say discrete random variable, a random variable X is discrete if it has finite or countable number of outcome. So when you look at the outcome, excuse me, when you look at the outcome of the experiment, and if the outcome of the experiment are countable, we say it is discrete variable. For example, number of calls made by college professor to his student in a day. So how many calls are made by a college professor to his student in a day? If we want to count that, it can be 1, it can be 0, maybe he had not called. It can be 1, it can be 2, it can be 3, or it can be 4, and so on. You will not have any decimal value or anything associated there. So this random variable is the discrete random variable because it will take only whole number like 0, 1, 2, 3, 4, and so on. It will not take any decimal value. That is the discrete random variable. The other one is called the continuous random variable. When we say a random variable X is continuous, it means that it has uncountable number of outcomes. So let's take the same example, number of calls made by college professor to his student in a day, but little differently. Number of minutes spent by college professor while calling his student in a day. How many minutes are spent on the phone by the professor while calling his students? It can be 2 minutes. Now from 2 minutes, we cannot say that he has just 3 minutes directly. Maybe he will have 2.1 minutes with some student, or 2.5 minutes with some other student, or 3.4 minutes with some student. So it can even take the decimal value. So if the random variable takes decimal value also, then it is called the continuous variable. But if the random variable takes the whole number only, like 0, 1, 2, 3, 4, then it is the discrete variable. Okay. Do you have any question on what is random variable, what is discrete random variable, or continuous random variable? Please unmute yourself. Any question in this one?
No, sir.
No question on that? Okay, fantastic. Now let's talk about the discrete probability distribution. In this chapter, we'll talk about the discrete probability distribution that is associated with the discrete random variable. So when we say the discrete probability distribution, it consists of the values of random variables. So when you look at discrete probability distribution, you will see the random variable, okay, that is the discrete random variable, and their probabilities. So for example, over here, in my example down here, look at this one. What I have is, here I have the X values. These are the random variables, okay, the random variables. And over here, I have the probability of each. Probability that X equal to 0 is 1/8. Probability that X equal to 1 is 3/8. Probability that X equal to 2 is 3/8. Probability that X equal to 3 is 1/8. So in this table here, you have the random variable and their probabilities. This is called the probability distribution. And because our random variable is discrete, this is called the discrete probability distribution. But when you just see a table like this, you cannot just say that this is the probability distribution. There are two important conditions that table has to meet so that it is the probability distribution. The first one is the probabilities P of X, these values must be between 0 and 1. So if you look at the values of probability, 1/8 is less than 1, 3/8 is less than 1, 3/8 less than 1, 1/8 less than 1. Less than 1, but more than 0. So if these values are less than 1 and more than 0, or if the probabilities are between 0 and 1, that is the first condition. All probabilities must be between 0 and 1. That is your first condition. The value of each probability in the distribution must be between 0 and 1. And the second condition is, if you add all these probabilities, it should be exactly 1. So if you add all probabilities, sum of P of X is equal to, you can see here, 1/8 plus 3/8 plus 3/8 plus 1/8. If you try to add all these, you can see you have a common denominator of 8. So 8 in the denominator. And if you add the numerator, 1 plus 3, 4, plus 3, 7, plus 1, 8. So it becomes 8 over 8, which is equal to 1. So the second condition is also true. So whenever the probability distribution is given to you and you are asked to check whether this is the probability distribution or not, what you have to look at is you have to check whether all probabilities are between 0 and 1 or not. All probabilities must be between 0 and 1. And sum of all probabilities must be 1. So for the distribution to be the probability distribution, both conditions must be true. Both conditions must be true. If one of the conditions is not true, it is not a probability distribution. So for the given probability distribution, or for the given distribution, if these two conditions are true, then we say that it is the probability distribution. Okay, now you can unmute yourself and answer my question. Do you have any question in the definition of discrete probability distribution? Please unmute yourself.
No, sir.
No, sir.
Okay, it's going good. Great. Okay, look at this example. Now you should start filling your note catcher if you have one already ready with you, or you can take a notes. Suppose X is the number of heads while tossing two coins. So they have given the random variable. Look at that. X is the number of heads while tossing two coins. So two coins are tossed and we are looking for the outcome, that is the number of heads. So what we are asked to do is we are asked to construct a probability distribution for the random variable X. When you are asked to construct the probability distribution, you want to create a table like this. That is the meaning of that. Okay, you are creating a table like this. So when you toss two coins, if you want to look at all possible outcomes, you already remember this from the probability chapter. You know that in the first, you'll get head or tail. And also in the second coin, you'll get head or tail. So if you try to list all possible outcomes, you'll see that here you'll have head and head, that is head on the first, head on the second. So head and head. Here you'll have head on the first, tail on the second. Head on the first, tail on the second. Here you'll have tail and then head, tail and then head. And here you'll have tail and tail, tail and tail. What we are interested is we are counting the number of heads. So everybody look at this table. How many heads are here in the first box?
Two.
Two. Okay, two. How many heads are there in the second here?
One.
One. How many are there in the third?
One.
One. And how many heads are here in the fourth?
None.
None or zero, right? So what we are looking at is X is the number of heads while tossing the coins. So we saw that the number of heads could be 0 or 1 or 2. That is your random variable X. So your X is 0, 1, or 2. Now, if you look at the table here, when you construct the discrete probability distribution, you need the X value and you need their corresponding probabilities. So here also we are going to find the probability P of X. So P of X. So this one, you can see 0 heads, we have one possibility. 0 head, we have one possibility out of 4. So this is 1 over 4 or 0.25. 1 over 4 or 0.25. Now 1 heads, you can see how many 1 heads are there. There are 2, right? 2 out of 4. So when you look at 1 head, you have 2 possibilities out of 4. So 2 over 4, that is 1 half or 0.5. And then 2 heads, the possibility of getting 2 heads, we have only one case out of 4. So 1 over 4 or 0.25. So this is our probability distribution. This is the probability distribution for the number of heads while tossing 2 coins. You can check whether it meets the condition or not. So if you want to look at this, you can see that all probabilities are between 0 and 1. So the first condition is true. All probabilities, all P of X, they are between 0 and 1. And if you want to look at the sum of all probabilities, if you want to add all of them, let's see, 0.25 plus 0.5, 0.75, 0.75 plus 0.25, that is 1. See, it meets the condition, the second condition, and also the first condition. So this is the probability distribution. So that was the first part of the question. We are asked to construct the probability distribution. See, construct a probability distribution for the random variable X. And then in the second part of the question, we are asked to represent it graphically. Whenever you are representing the probability distribution graphically, what you have to do is you have to make a histogram to represent this data. So whenever you are asked to represent the probability distribution graphically, all you have to do is you have to construct the histogram to represent the data. So let's construct the histogram. You can follow along with me. So in order to construct the histogram, you know that you need the x-axis and y-axis. So we'll draw that. Suppose that is my x-axis. Let's also draw the y-axis. Suppose that is my y-axis. Now we are going to label this. Along the y-axis, we need to label the probability P of X. So I'm going to go by 0.25, 0.25. Then you'll have 0.5, 0.75. Then you'll have 1. And your random variable along the x-axis. So along the x-axis, you have your random variable, which is 0, 1, 2. So you can mark here 0, here 1, here 2. And then we need to draw those vertical graphs. So we make that bar graph here. So 1 is 0.25. You can connect them if you want, but I'm just going to draw the bar. That's okay. 0, when you have 0, the probability is 0.25. So 0 has the height of 0.25. So we draw that bar there. 0 has the probability like that. That's your first one. 0 has the probability 0.25. You can write the probability on the top if you want. And if you don't write, that's totally fine. If you just leave it like that, that's fine. Okay, second, we have the x equal to 1. When x equal to 1, the probability is 0.5. So here you go up to 0.5. You can make the connected bar, no problem with that. That'll be a histogram. We can do like this. It really doesn't matter because we are just representing this. Okay, when it is 1, it is 0.5. We got that. Then we have the 2, random variable x equal to 2. The probability is 0.25. So we go to this height and we construct it like this. So this is the probability distribution for the number of heads while tossing 2 coins. So we complete the problem, but I have a question for you. Please unmute yourself and try to answer this question. By looking at the distribution here, I represent the distribution graphically over here. By looking at the distribution, tell me whether this is skewed to the left, is skewed to the right, or it is normal. What do you see? Please unmute yourself.
It is
Normal.
normal.
Normal. Normal.
It is normal. Very good. So when we start working on the probability distribution in all upcoming sections, we'll look at whether the distribution is normal or not. So here, this is normal because you can see the tallest height is here, and then we have the equally spread data on the left and the right. So it's normal or bell-shaped. Very good. Next example. Let's see what you are asked to do here. Determine whether the following distribution are probability distributions. So these distributions are given to you. You have to check whether these two distributions are probability distributions or not. And we already know for the distribution to be probability distribution, the probabilities must be between 0 and 1, and sum of probabilities must be 1. So let's look at the first one. In part A, do you think that all probabilities are between 0 and 1? Please check there. Yes or no?
Yes.
Yes. So here, the values of probabilities, the values of P of X are between 0 and 1. So the first condition is true. Okay, you can write like this, or you can write sentence that is okay. Probabilities are between 0 and 1. And if you want to find the sum of all probabilities, let's see. Sum of all probabilities, whether it is 1 or not. 0.1 plus 0.2, that's 0.3, 0.3 plus 1, 0.4, 0.4 plus 0.4, 0.8, 0.8 plus 0.3 is 1.1. You can check in your calculator. So is it 1 when you add all this? Is it 1?
No.
No, this is not equal to 1. So does it meet those two conditions of probability distribution? Is this distribution satisfying those two conditions? Yes or no?
No.
No,
No.
sir.
That means, is this a probability distribution?
No.
No, it is not a probability distribution. So let's write this down. This is not a probability distribution. Make sure you write that sentence. That is your first part A. Let's look at B. We have similar thing. You have the X values, and then they have given the probabilities. Let's find out whether the probabilities are between 0 and 1 or not. Are these values between 0 and 1? Look at that. 1/4, 1/2, 1/8, 1/4 is 0.25, 0.5,
Yes.
and this is 0.125. So everything is between 0 and 1, right?
Yes.
So first condition is true. The probabilities are between 0 and 1. And let's find out the sum of probabilities. If you add all probabilities, let's find out. 1/8 plus 1/8 is 1/4. 1/4 plus 1/2 is 3/4. 3/4 plus 1/4 is 4/4 or 1. So this is exactly equal to 1. So probabilities are between 0 and 1, and sum of all probabilities is 1. So is this a probability distribution?
Yes.
Yes. So this is a probability distribution. This is a probability distribution. Okay. Do you have any question in this one?
No.
Okay, great. Next example here. So it's related to the fundamental definition of probability distribution. Fill in the probability x equal to x, that is probability of x equal to 1 and x equal to 2. You can see they are blank here. Okay, we have to fill that in this table below so that it gives a legitimate probability distribution, so that this will be a probability distribution. Random variables are 1, 2, 4, 5, 6, and the probabilities are given. What we know is for this table to be probability distribution, all probabilities, including the probabilities in these two blank space, plus these probabilities must be equal to 1, and these probabilities must be between 0 and 1. These are already between 0 and 1. So what we know is this. Let's do this. Let's add all these. So probability when x equal to 1, we don't know what is that. When x equal to 1, what is the probability? We don't have that. When x equal to 2, we don't have that. Probability when x equal to 2, we don't know that. Plus this, plus this, plus this. If you add these three, you can do that in your calculator. Please add in your calculator 0.14 plus 0.25 plus 0.20. What did you get?
0.59.
0.59. Okay. So if I add all these, so I add this, this, and all this, that should be equal to how much?
1.
1. That's equal to 1. Very good. Now let's subtract this 0.59 on both sides. Please subtract 0.59 on both sides. What did you get? Probability of x equal to 1 plus probability of x equal to 2 equal to how much?
0.41.
0.41. 1 minus 0.59, that is 0.41. That means we have to select the two probabilities values here so that the sum is 0.21. So there are so many answers. There are so many possibilities. So one possible answer is, let me write here, one possible answer would be, instead of writing one possible answer, let me write possible answers, and I'm going to list a couple of them. Possible answers. So we are looking for probability when x equal to 1 and probability when x equal to 2. We are looking for those two. The sum of those two should be 0.41. So it can be 0.40 and 0.01. Is it 0.41 if I add those two?
Yes.
Yes. So that is one possible answer. And the values are between 0 and 1. Okay, and the total is 0.41. If you add that, it will be 1 again. So that is one possibility. The other possibility that I can show you is this: 0.20 and 0.21. 0.20 and 0.21, is it 0.41 again?
Yes.
Yes. So there are so many possible answers. You can write any. Okay, you can write any. There are so many possible ways of writing the values of these two. You can write any. So that is the answer to this one. It can be any. So I'm going to fill with one answer. So let me fill this as 0.20 and 0.21. There are so many possibilities. Okay, this is kind of open question. So everybody may have a different answer, but the sum of those two should always be 0.41. Any question in this?
No.
No question on that? Okay, great. So now we have the fundamental idea of the probability distribution. And when you look at the probability distribution, you have the value of x and you have the value of p of x. We have the value of x and p of x. It looks very similar to the frequency distribution that we have seen in chapter 3. So what we are going to do is now we are going to calculate the mean, then standard deviation and variance for the discrete probability distribution. So we have the set of formulas to look at before we go to that. And here we go. When we say mean, there are two things, they look very similar here. That is the mean and the expected value. Mean and the expected value of probability distribution, they are both the average values. So the way we calculate mean we write mu, or expected value we write E of x. The formula is same. It is the sum of x, that is the random variable, times the probability P of x. So that is the formula to find the mean. So please write down that formula in your notes. Mean or expected value is equal to sum of x times P of x. That is the first formula that you need to know. And the second one, the variance, okay, which is the, you know that the variance is the square of the standard deviation. So we write sigma squared, that is your variance. Sigma squared is the sum of x minus mean squared times P of x. Okay, write that formula also. Sigma squared equal to sum of x minus mean squared times P of x. That will give you the variance. So if you want to find the standard deviation, you just take the square root of that. So for the standard deviation, you'll just take the square root of that. Okay, I hope you copied those formulas. Now, let's take examples. Here is our first example on that. So here they have the random variable x, and also the probabilities are already given to you. So this is the probability distribution or random probability distribution of discrete variable. We have to find the expected value, that is the mean, variance. So we are looking for the mean or expected value, and the variance of this probability distribution. So if you think of mean, let's recall, what was the formula for mean? Tell me, mean or expected value, what is the formula? Who can tell me? You can unmute yourself.
Sum of x times probability of x.
Very good. It's the sum of x times the probability of x. And what is the formula for variance, which is sigma squared equal to? Sum of x minus mean, the quantity squared, times the probability of x, right? That is the formula. So let's use this formula to calculate the mean and the variance. So first, let's make a table with x that's already given to you, 10, 20, 30, 40. Then probability of x is also there. It is 0.05, then 0.7, 0.15, then we have 0.1. That is your x and p of x. Now you can see here in the formula, in order to find the mean, we need x times p of x. So in next column, I need x times the probability of x. Please get ready with your calculator to multiply these values. And then as I ask you, please multiply and tell me the value. What is 10 times 0.05? Because we are multiplying x times p of x. 10 times 0.05 is how much? 0.5, very good. And then what is 20 times 0.7? Do you want to be a little bit louder? 14, right?
1.4.
1.4 or 14, or what is it?
1.4.
1.4?
1.4. Yeah.
1.4, okay. And then the next one is 30 times 0.15. How much is 30 times 0.15? I want you to multiply, please, everybody. I want you to multiply this one more time. 20 times 0.7, please.
I got 14.
14 is the right. 14, okay. How much is 30 times 0.15? 30 times 0.15.
4.5.
4.5, very good. And how much is 40 times 0.1?
4.
4. Okay. Now you can see we multiplied x times p of x, and you know that the mean is the sum of all these. So in your calculator, please add these numbers, x times p of x. When you add all these, what do you get? Please add and tell me the result. When you add, what do you get?
23.
23. So our expected value or expectation, which is also the mean, is 23. So the first answer is expectation, which is also the mean or average, is equal to 23. So we got that from the table. Now next, we are asked to find the variance. Variance is given by this formula. We need to find x minus mean squared, then times p of x. So in next column here, we are going to find x minus the mean. Our mean is 23. So x minus 23. First, we have to perform that. And then we have to square it, x minus mean. Then we have to square it and multiply by p of x. Okay, and multiply by p of x. So for example, in the first one, see over here in the first one, when you do that, x is 10. So this is 10 minus 23 is squared times your p of x for the first is 0.05. 0.05. If you do that in your calculator, what do you get? Make sure you type it like this. First, you have to open the parenthesis, then 10 minus 23, parenthesis close, then hit that square sign in the calculator times 0.05. What did you get? Is it 8.45? Make sure you check it. It should be 8.45. Now, if you go to the second, same thing. It is 20 in this case. Our x value is 20. So 20 minus 23 squared times the probability this time is 7. So 0.7. Use that in your calculator. Type that in your calculator. You should get 6.3. Next one, your x value is 30. So it is 30 minus 23 quantity squared times your probability is 0.15. If you type this in your calculator, make sure you type and check it. You should get 7.35. And the last one, your x is 40. So 40 minus 23 squared times the probability there is 0.1, so 0.1. And if you do that, you should get 28.9. Okay, that is the value for x minus mean squared times p of x. Now, if you look at the formula, go back and check it. It is the sum of all these. So please add these numbers and tell me what you'll get. 8.45 plus 6.3 plus 7.35 plus 28.9. Please add those numbers in your calculator and give me the sum. I just need the sum.
51.
51.
51.
51.
Good. Okay, the sum is 51. So that means your variance, which is the sigma squared, is equal to the sum of all these. So when you add all these, it is 51. So that is the variance. So we are asked to find the expected value and variance. We got that. In this question, we are not asked to find the standard deviation, but we are just going to do it so that we know how to find the standard deviation. So if we are asked to find the standard deviation, what is our standard deviation? If you remember, is the square root of the variance, right? So it's square root of 51. So do it. How much is the square root of 51?
7.1414.
Okay, 7.1414. That is the standard deviation. So sometimes in mastery exercise, after you do all these, you'll be asked to find the standard deviation. All you have to do is take the square root and you will get that. Okay. Do you have any question in this?
No.
No question on that. Very good. So what we are going to do now is, as the session is about to end, we are going to take a 10 minutes break. It is 9:40 now. We'll come back and start at 9:50. Is that okay?
Yeah.
Okay.
Yes.
Welcome back. We have one more example to finish from today's lecture. And this is the last example. It is still based on the discrete probability distribution. Let's read the problem. At a raffle, 1,000 tickets are sold at $3 each for 4 prizes. So they sold 1,000 tickets and the price of each ticket is $3 and they are giving out 4 prizes. You can see the first one is a $500 prize. The second is $300 prize. Third is $200 prize. And the last is $100 prize. Now what we have to do is, what is the, somebody's asking a question? No? Okay. What is the expected value of the gain if you bought 1 ticket? So first you need to understand the question very nicely over here. You can see there are 1,000 tickets sold at $3 each. They are giving out only 4 prizes. The first is $500, the second is $300, the third is $200, and the fourth is $100. And what you're asked to calculate is the expected gain. What is the average gain you'll have by buying 1 ticket? Is this question clear to everyone? Just say yes or no. Please unmute
Yes.
yourself. Okay, the question is
Yes.
great. The question is clear. So we are calculating the expected gain or loss. So what I'm going to do is I'm going to call that X, the random variable X, as the gain. X is the gain. Okay, gain on buying 1 ticket. So what I'm going to do is, because we are asked to find the expected value, in order to find the expected value, we need that probability distribution, because once we have the probability distribution, the expected value is the sum of x, the random variable, times the probability of x. We already defined what is x. X is the gain. So let's write those gains. Please work with me here. Suppose if you get a $500 prize, what is your gain? Who can tell me? If you win a $500 prize, what is your gain? You already spent $3 on the ticket. So what will be your gain?
1.
497.
$497. Very good. $497. Great. If you get $300 prize, if you win $300 prize, what is your gain? What is your gain? Please unmute yourself when you talk.
297.
297. There we go. Look at that. It's not that difficult. If you gain, or if you get $200 prize, what is your gain?
197.
197. Now you have the idea. If you get $100 prize, what is the gain?
97.
$97. And if you don't get any prize, what is the gain?
Minus $3.
Minus $3 gain. That's lost, right? Minus $3. Very good. So this is your random variable. Okay, this is the random variable. In probability distribution, we need the random variable x and their probabilities. So in next line, we are going to find their probabilities, P of x. Okay, so how many $500 tickets they are giving out? I mean, how many $500 prizes they are giving out?
4.
No, $500 prize, how many? They are giving 4 prizes. One is 500, one is 300, one is 200, one is 100. So just one, right? One out of how many tickets?
1,000.
1 out of 1,000. So the probability of gaining $497 is 1 out of 1,000. Similarly, probability of gaining 300 is also 1 out of 1,000. Okay, probability of gaining, the next one we have here is 197. That is also 1 out of 1,000. And then probability of gaining 97, they are just giving $100. That means 1 out of 1,000. They are just giving these 4 prizes. One with $500 back, one with $300 back, one with $200 back, and one with $100 back. Okay, so 4 prizes they are giving out. So what is the probability that you lose? What is this one? Out of 1,000, you can see here, out of 1,000, they are giving out 4 prizes. This is negative, meaning they are not giving out how many prizes? They sold 1,000 tickets. They are giving prizes back to 4 tickets only. So how many tickets are not getting the prize?
996.
996, which is 1,000 minus this 4. So it is 996 out of 1,000. 996, let's write that down. Okay, 996 over 1,000. So this is our probability distribution. So once we have the probability distribution, we know how to find the expected value. Just buying 1 ticket, what is the average loss? So if you want to find the expected value, our formula is the sum of x times P of x. So what we have to do is, we have to multiply these values and add them together, right? We multiply these 2 values and add them together. So if you multiply 497 times 1 over 1,000, it is same as 497 times 1 divided by 1,000. So that is 497 divided by 1,000. Is that right? Because when you multiply, you just multiply the numerator with numerator and denominator with denominator. For this 497, the denominator is 1. 1 times 1,000 is 1,000. So similarly, 297 times 1 over 1,000 is 297 over 1,000. And then 197 times 1 over 1,000 is 197 over 1,000. And then 97 times 1 over 1000 is 97 over 1000. Then after that, we are adding a negative. When you add a negative, the result will be negative. Then 3 times 996. You can do that in your calculator. How much is 3 times 996? Is it 2988 over 1000, right? 2988 over 1000. So do you have any question up to this point? Unmute yourself and say yes or no.
No, sir.
Okay, now let's work together in our calculator. See, we have a common denominator of 1000, no doubt on that. So the denominator is 1000. In the numerator, you have to do 497 plus 297 plus 197 plus 97 minus 2988. Please unmute yourself. I can hear some noise at the back. Thank you. Okay, please add these numbers. 497 plus 297 plus 197 plus 97 minus 2988. Unmute yourself and give me what you get. What is the result? I got negative 1900. Make sure you check it. That's what it should be. 497 plus 297 plus 197 plus 997 minus 2988. I got negative 1000. Now, when you divide this negative 1900 in the numerator divided by 1000, that is equal to negative 1.9. That means when you buy one ticket in this program, there is an average loss of $1.9. So we are calculating the gain, but we got negative. Meaning of that is there is expected loss of $1.9 by buying one ticket. So let's write that. There is expected loss of $1.9 or $1.90 by buying one ticket. Okay, so that is the end of the lecture for today, because in next section or the next half of the chapter, we have the binomial distribution. In this one, we talk about the discrete random variable.